In this lesson, I'll provide you an overview of the steps involved in the fine-tuning of a model. The process will begin with the selection of a base model for fine-tuning. When selecting a base model, it's crucial to ensure that it aligns well with the specific task at hand. Suggestion is to define clear model selection criteria. One key criteria is the performance requirement. For example, if the task only requires around 80% accuracy, a large and complex model may not be necessary. Opting for a smaller, more efficient model can meet your needs while saving resources. Data security and privacy is another major consideration, particularly for enterprises. Many organizations prefer to avoid closed source model due to data privacy concerns, especially since these models are often accessed via third-party APIs. In such cases, self-hosted open source models can offer a more secure alternative. Cost is always a critical factor. The cost of using third-party models, especially the closed source models, can quickly add up. With self-hosted open source models, the costs depend on your infrastructure. So selecting a model that isn't excessively large can help reduce compute resource usage, resulting in lower operational costs. Consider the community and ecosystem support for the model as well. A strong, active community can make a huge difference, providing quicker answers to questions and troubleshooting issues. Also assess the model provider's commitment to the model family. You don't want to rely on a model that might be discontinued or lack support in the near future. Make sure the provider is committed to maintaining and supporting the model for a reasonable amount of time. Keep in mind that these are just some of the criteria or factors to consider. Feel free to add your own list of criteria or factors depending on your needs. At this stage, you should have selected a model family and a targeted model size. For example, if privacy is a concern, then select Llama family of model and self-host it. If performance is the biggest concern, you may want to select a closed source model such as GPT-4. Next step involves defining the evaluation strategy. Setting up the evaluation strategy before fine-tuning a model is like following a test-driven development approach for fine-tuning. In test-driven development approach, you write the test cases before developing the code, and similarly here, we are defining the evaluation criteria and preparing test cases for the model before the fine-tuning process begins. This ensures that we have a clear understanding of how to measure success and we can verify improvements effectively once the model has been fine-tuned. A common approach is to create a task-specific test or evaluation dataset with unseen data. This dataset should include edge cases to evaluate how the fine-tuned model handles novel patterns and unexpected inputs. By testing an edge case, you can assess the model's robustness in real-world scenarios. Evaluation is carried out with an automation that consumes the test dataset and generates a report. However, for some tasks, automating the evaluation may not be feasible. For example, tasks like fraud detection can easily be automated, as the output are typically binary or measurable. In contrast, tasks such as legal document summarization requires more nuanced evaluation, making it difficult to assess the quality of the output purely through automated means. For such scenarios, human feedback may be needed. Subject matter experts can evaluate the model's output by manually reviewing the response and scoring the model's responses. With humans involved in the feedback, scale becomes a challenge. So, to scale this process, you could use a larger LLM as an automatic evaluator, allowing it to judge the output instead of the humans. This can provide faster evaluations at scale. Such a use of LLM for evaluation is referred to as LLM as a judge. The next step is to prepare the dataset. This step is crucial because the quality of the training data directly impacts the performance of the fine-tuned model. This step involves pre-processing the dataset, such as removing the duplicates, formatting the data to fit the task requirement, and ensuring compatibility with the base model. It's important to ensure that the dataset is balanced. For example, for the fraud detection task, you should aim for an even split between positive and negative samples to prevent bias. You will also need to split the dataset into training, validation, and test sets to ensure proper model evaluation. In addition to quality, quantity matters. A small dataset may cause the model to overfit, leading to poor generalization. When it is difficult to gather enough data, data augmentation techniques can be applied to generate synthetic data and boost the dataset size. Now we move on to the actual fine-tuning process. The specific steps will depend on the fine-tuning library or framework that you are using. For closed source models, you will typically fine-tune using the model provider's API or SDK, following their guidelines and tools. Next, you will execute the evaluation strategy to assess the performance of the fine-tuned model. If the results meet your expectation, the model is ready for inferencing. However, if the response quality is not satisfactory, you may need to adjust the hyperparameters and run the fine-tuning process again. Remember, this is an iterative process that may require multiple attempts to achieve the desired quality levels. If after adjusting the hyperparameters, the output quality is still not acceptable, you may need to revisit your fine-tuning dataset. You need to assess the dataset's quality, quantity, and coverage. I'll go into more details about dataset preparation and adjustments in a later lesson. In the worst case scenario, if adjusting the dataset still doesn't improve the output quality, you may need to consider using a different base model for the task. In this lesson, you learned about fine-tuning process. In the next hands-on exercise, you will create your first fine-tuned model. Happy learning, and I'll see you in the next video.